Good afternoon, everybody. My name is Lynn Hediger. I am Vice President of Manufacturing and Product Engineering for Orbis Corporation. Orbis specifically, we do reusable plastic packaging and steel packaging. Orbis, interestingly enough, is Latin for loop. The notion of it's reusable, it's recyclable. Okay, so sustainability is at our core. That is our big business. But 4 or 5 years ago, my team sat down. We were trying to figure out how do we drive our improvement for our uptime and reduce our unplanned downtime, obviously. And so we put together some goals of trying to, what would we want out of an IoT system? And we sat down and said, well, first and foremost, like everybody else, we want a predictive maintenance model instead of an interval-based model. So we wanted something, a very simple dashboard, a check engine light, if you will. Likewise, to our improved field service, our suppliers tended to send in a technician. Again, you say your machine's not running, they send a tech out. Maybe they sent the control guys and it turns out to be a hydraulic issue. He shows up 2 days later, says it's not what I can fix, makes another phone call, it's another 2 days before the next technician can come out and help you. So we wanted to get better with that. The bottom one was near and dear to my heart as we were putting this vision together. Are we ever gonna build enough history to know if we're making a difference or what's really happening? Or is it just an anomaly, one-off type of thing? So I wanted to be able to put the onus back on our suppliers to say, hey, you got tens of thousands of these molding machines out there. Connect up all of them and you can learn and teach us and we'll teach you and make a symbiotic relationship out of this. We chose to work with our largest press supplier, which is a company by the name of Millicron. Again, another company that's been around forever. We went to them and said this would create a competitive advantage. There was nobody in the world of injection molding that was doing IoT per se. So we gave them our vision. They liked what we were talking about, thought it was a service they could sell. And so they partnered with a company by the name of EI3. And the EI3 really was the team that was able to put the data scientists behind it. So Orbis again jumped in as a beta partner to Millicron and EI3 back in 2019. Today we've got 22 machines connected. There's 34 different things that we're actually monitoring on each of these machines, and there's 250 unique algorithms that are being calculated a lot. What I wanted to try and share with this group is just some specific details of applications where we've used sensors and so forth to improve our operations. We make a lot of plastic containers. Most of this is done on plastic injection molding machines. Plastic drops in on the left side at the hopper. They come in granules. It goes into an injection unit, which is basically going to melt that plastic. There's a screw and barrel. The screw augers the material forward, creates some friction to help melt it. Then there's some heater bands around the outside. So that's what we would consider in a very simplistic model. That's the injection unit. On the other side of the center plate there where the nozzle is where the mold sits. And on that side, there's a clamping mechanism that opens and closes that mold. It's a hydraulic-based system. We did a Pareto analysis. We were actually very data-oriented, had a lot of history, and we were able to say, okay, these are our top 3 or 4 items that were causing our downtime. And it was heater bands, hydraulic pumps, and then the feed screws on the machine. So we started off with heater bands. And I would have said the team within maybe 2 to 3 months came back to us and said, here's an algorithm that's going to tell you whether that heater band is on its way to failing or not. On the bottom one is an example. When the green line and the orange line start to separate, that heater band is starting to draw amperage at a different level than normal. It's on its way to failure, all right? Nice part about this, on these 22 machines only, the first year we saw over 7,000 hours of unplanned downtime go away. Because we could then we could get to a point where when a heater band was failing, we could schedule it to be replaced while we were doing a mold change. And now we're not incurring the extra downtime. So it was a huge win for us. We also started to see part quality better. So typically in our world, 3-4% scrap rates are pretty normal. We saw a 1% drop in that. The next one that we took on was pump health. And again, the hydraulic pumps is the next biggest pain point that we would have. Pump goes bad, it tends to disintegrate. It throws what we call glitter into the oil. So the brass starts to come undone and it tears up your machinery as a result. The EI3 team in Millicron developed what they call their Symphony vibration sensor. It's also a sound-based sensor. But they could start to track, and you can see in the upper left-hand corner where that particular mold running was typically normally on the lower end of that range, and all of a sudden we started to see a ramp up. And so we took that pump offline where the red line crosses and said, let's just go ahead and proactively replace it. sent it out, had the pump tore apart, took a look, and on the inside it was all galled up and about ready to fall apart. We were able to use that technology now where we can create predictions on this. We can tell about 2 months before that pump's gonna go bad, that it's gonna go bad. The pumps, for us, it doesn't show like it's a huge savings. You know, it shows 48 hour, roughly it's about a day and a half to 2 days to transition that. But the reality is if we don't do it, the glitter oil then starts tearing up the valves, it starts tearing up the seal kits in the machine, and we have all kinds of problems. So it becomes a multiple month just series of issues if we don't take care of it. This one I'm going to gloss over a little bit, but one of the nice parts of this is for our feed screws. We started analyzing energy, so we didn't have to put any new sensors on. We were able to take information coming from the machine, put it into a machine learning type of environment, and it could tell us when we were starting to see ramp up of electrical usage. That became an indication for us that our screw was wearing and would give us enough notice that we could get a replacement ordered in time. It's also given us the opportunity to make more parts per year because it's giving us feedback as to how we've got the machine set. So we've saved, on one machine alone, we saved over 18,000 kilowatt hours for that 1 year. So again, it helps us with our sustainability story internally as well. And I think that's about what I got.